Hello and welcome back to Introduction to Number Theory. As we saw in the previous video, we can sum, we can subtract, and we can also multiply quadratic irrationalities, and we will always gain, again, quadratic irrationalities with integer coefficients. And what about the division? Let's talk about the division in the ring z of the square root of a. Say, take z1 and z2, which are, of course, both represented in the form integer plus integer multiplied by square root of a, where x1 and y1 and x2 and y2 are all integers. And let's try to divide one of them by the other. And during this, we will need something that is sometimes called a fifth arithmetic operation. It is the conjugation, and we will need z2 conjugated, which is equal to x2 minus y2 multiplied by square root of a. And this is the very place where we need the uniqueness of the representation, because you understand that if z2 had several different representations, then we wouldn't know in which of them we ought to exchange plus for minus. And since this representation is unique, then in this unique representation we simply change the plus with the minus and gain z2 conjugated. So, z1 over z2, which is equal to this fraction. I don't think I need to read it. But what do we do with it? Of course, we will multiply the numerator and the denominator with z2 conjugated. So we'll gain something even more frightening and even more complicated at the first sight. But when we multiply the two parentheses in the denominator, we will gain an integer number equal to x2 square minus a multiplied by y2 square. And something quadratically irrational in the numerator. So when is this a quadratic irrationality with integer coefficients? Of course, the first part, the integer part of the numerator, and the irrational part of the numerator should be divisible by the denominator. Let's denote the denominator as d. And in some sense, in the sense of the ring z of the square root of a, this expression can be treated as a norm of the element z2. So after we denote this denominator by d, we understand that x1 multiplied by x2 must be congruent to a multiplied by y1 multiplied by y2 modulo d, and also y1 multiplied by x2 must be congruent to x1 multiplied by y2 also modulo d. Well, these conditions seem rather unuseful, rather difficult. Well, if these conditions hold, then z1 over z2 has indeed integer coefficients and is equal to integer plus integer multiplied by square root of a. Why are we now talking about these conditions? Well, during our study of the Pell's equations, which we haven't introduced yet, but nevertheless, there will be a moment when we'll need to use this corollary of the division of z1 by z2. So when we get that moment, I will remind you of this video, and we will use these conditions, these congruences modulo d. Well, for now on, we know that sometimes indeed, an quadratic irrationality is divisible by another quadratic irrationality. And in our next video, we'll talk about such quadratic irrationalities that any other quadratic irrationality is divisible by these. We'll talk about invertible elements of this ring.